Hello and welcome to a lesson on the sine law. What happens if you have a triangle that wasn't 90 degrees? So every lesson before this is dealing with triangles that were only 90 degrees. SOHCAHTOA, sine, cosine, and tangent, those ratios, those primary trig ratios, can only be used for 90-degree triangles. So now we're moving on to the next part. We're going to be introducing something called the sine law, which can be used for triangles that are not 90 degrees. So let's take a look here. So we have an example here of a triangle that is not 90 degrees, and we're going to try to develop a formula called the sine law using what we do know, which is the primary trig ratios. So if we're going to try to use our primary trig ratios, we need a 90-degree triangle somewhere. So the first thing they do is draw something called an altitude. An altitude is something that is drawn starting from one vertex and drawn to the opposite side, and that lands at a 90-degree angle. Okay, so this is an altitude. And now what we can do here is now we have triangles that are 90 degrees. So by introducing this altitude, we can now use our primary trig ratios, which involve and need 90-degree triangles. So the first thing they did here was take a look, and they chose a focus angle of angle A here. So angle A is our focus angle. As a result, if they want to use a sine ratio, the opposite to this focus angle is H, and the hypotenuse is C. So as a result, they've written sine of A is equal to opposite, which is H, over hypotenuse, which is C. Now, what happens next is they took a look at the second triangle that they've created and used angle C as a focus angle. And with angle C as the focus angle, H is still our opposite, and in this triangle, A becomes our hypotenuse. As a result, using the formula opposite over hypotenuse, sine of angle C, focus angle C, is equal to opposite, which is H, over hypotenuse, which is A. Now what we're going to do is isolate for H for both of them, okay, because H is in what's common for both of these triangles. So let's isolate for H. So in order to isolate for H, this is dividing by C. The opposite of dividing by C is multiplying by C. So if we're going to multiply both sides by C, we're going to have C times sine A, which is what this is. We have isolated for H entirely. And the same thing goes over here. We want to get rid of dividing by A. To get rid of dividing by A, we multiply both sides by A, so it becomes A times sine C. And now what's useful about this, I don't know if you remember from our very first unit, which is in linear systems, if you have something that's both equal to H, right? This is equal to H, and this is also equal to H. They're both equal to that height. That means they can be both equal to each other. And what do I mean by them? This is C sine A is equal to H. A sine C is also equal to H. If they're both equal to H, that must mean they're both equal to each other. And so that's what we've written here. We've taken this and made them equal to each other. And so, in order to get all the letters on the same side, what they've decided to do is they've decided to. Okay, let me re-explain this. See how this is A and C on this side of the equation, and on this side of the equation this has sine C and angle A. In order to clean this formula up, you want all the letters on one side. So we're going to move this A to the other side. So to move that A, we're going to divide both sides by A. And to get rid of this C, we divide both sides by C. Okay? And so that's the result of that. Now, there's another way of getting variables on one side. You can, instead of dividing by the lengths, you can divide by the angles, the ratio here. So this is C times sine A. What's the opposite of C times sine A? You can divide by sine A. So you're going to divide both sides by sine A. And same thing over here. This is A times sine C. I'm going to divide both sides by sine C. And as a result, if you're dividing by both of them, they're going to be on the denominator here. And this is something crazy because we have just created an equation, a formula that relates the original angle A and side A, and relate that to the angle of C and little c. Why is that important? Because we've created a formula that relates sides and angles of a non-90 degree triangle. We have eliminated this H portion altogether. There is no H here, which is amazing. Okay, we used H as a tool to help us relate this angle and this angle and this side and this side. Now, there's something missing from this triangle. We're missing something about side B, with angle B and side B. That's what we're missing. So in order to do that, I don't want to go through the whole process again, but instead of creating an altitude from angle B down to side B, in order to relate these two triangles, angle B and C, you draw an altitude from angle A all the way down to the opposite side. I'm going to go back to over here. Do you see how over here, this is an altitude from angle B? If you draw an altitude from angle A, you get this one, and you can relate these two triangles. And if you do the exact same process as the previous one, what you can do is you can actually find out that they're all equal to each other. So you get sine B over B, which is the same as A and C. You can relate B's and the A's and the C's. And you see how this is with the angles along the top, and then the lengths, which are lowercase letters, along the bottom. And you can see how you can flip it, and that's the exact same thing that's happening here. So right here, this is the sine law. Two versions of it. One with the angles along the top, or the length. Okay, and what I've done here for you is summarize. So this is the sine law in two different forms for any non-90-degree triangle. We have related all the sides of a non-90-degree triangle with all the angles of a non-90-degree triangle. And now we have a relation between all of them. In an equation, we can use them to solve for unknown sides and lengths. All right, click on to the next video and we can do an example.